Have you ever wondered why Intel's compiler seems to prefer using neg and add instructions instead of a simple sub? It's a curious choice that has puzzled many developers. Today, we're diving into this intriguing question and uncovering the reasons behind it. I totally get it. It can be frustrating when you notice something that seems inefficient in a tool you rely on. You're not alone in this observation. Many developers have encountered similar quirks with compilers. Here's the specific question we're addressing today. Why does Intel's C compiler tend to emit a pair of neg and add instructions instead of a single sub instruction? This has been observed in various code snippets, and it's a pattern that raises eyebrows. To understand this, we need to look at how Intel's compiler translates code into machine instructions. For example, in a simple modulus operation, the compiler chooses neg and AE, while others like MSVC and GCC opt for sub. What could be the reason behind this? Stay with me, because by the end of this video, you'll have a clearer understanding of compiler optimizations and maybe even some insights into Intel's design choices. To understand why Intel's compiler prefers the neg and add instructions over a single sub instruction, the user should first consider the architecture of Intel processors. The architecture is designed to optimize certain instruction patterns. Next, the user should analyze the performance metrics provided by Intel's Architecture Code Analyzer. This tool shows that the throughput for neg and ADD can sometimes be better than sub, depending on the context. The user should also consider the impact of instruction decoding. Modern CPUs often decode instructions into simpler microoperations, which can affect performance. This might explain why neg and ADD are chosen. Finally, the user should reflect on the overall efficiency. While neg and add may seem less efficient in isolation, they could potentially reduce pipeline stalls or improve execution in specific scenarios. Fun fact: the world of compilers is filled with quirks and optimizations that can sometimes seem counterintuitive. It's like a puzzle that developers love to solve. Now let's look at the answers provided by other users. One user offers a straightforward explanation. They believe Intel's compiler isn't optimal. They suggest that when developing a compiler, basic operations like add and nope are prioritized, while sub might be overlooked in favor of using neg and add. This could lead to less efficient code generation, especially in specific cases like calculating remainders. So what can we take away from this? Understanding these compiler behaviors can help us write better code and make informed decisions about optimization strategies. And there you have it. We've explored why Intel's compiler might prefer neg and add over sub. If you found this video insightful, don't forget to subscribe for more tech deep dives and tips.